My name is Chuck Cox, and on behalf of Freedom Communication Technologies, it is my great pleasure to present this how-to video on tuning a duplexer. For those of you who might be following along with your service monitor, I would like to start out by having us reset our service monitors to the factory default configurations so that you can follow along. We can do that by pressing the blue test button, then selecting presets. The fourth vertical soft key down is labeled load factory configuration. This is going to take about 30 seconds. While that's happening, let's review a little bit about what we know about duplexers. So in the situation where we have a base station or a repeater, we have both a transmit site and a receive side. They're operating on two separate frequencies, depending on which band they might be very close or a little further apart from each other. But we want to connect them to a single antenna. Obviously, we can't just wire everything together. We want to keep the transmitted signal from blowing away our receiver. We need some sort of device here, and that device is a duplexer. The job of a duplexer is to take one frequency, in this case frequency 1 is the transmitted frequency, to pass it out to the antenna, but to block frequency number 2, which is coming through the antenna, from getting into the transmitter, and vice versa. We want frequencies being received by the antenna. We want to block the signal that's coming from the transmit side, and we want to pass the receive frequency, and only the receive frequency, into the receiver. This duplexer is a type of RF filter. Now, as you may be aware, there are several different types of duplexers. Today I'll be using a pass reject, and I'll show you a little bit more about that in a second. Okay, so most likely you know a lot about duplexers. You probably know more than I do. What I'm primarily here to do is help you to understand how to set up your service monitor, in this case the R8100, or if you have an R8000, this is very similar. Now, the specifics that I will be using today is that I'm going to have a duplexer that has a high pass or a high side at 465 megahertz and a low side at 460. So let's dive in right away and let's set up our service monitor. In order to access the tracking generator, we press the blue button labeled Instrument. This presents us with a selection menu. I then select tracking generator. And then very quickly I have loaded up the tracking generator. Now, the first thing I want to do is to set my center frequency, and I'm going to set it right between the two high and low pass frequencies. So in this case, I'll set the center frequency to 462.5. By the way, if you're interested, the application that I'm running here to control my RD100 is the remote front panel application. It requires an optional remote option installed on the service monitor, but it allows you to hook up your service monitor to your network infrastructure, either locally, or you could even hook up your service monitor at a remote site and access it. If you're more interested in finding out more, you can contact sales or contact myself. Okay, so we've got now the center frequency set. The next thing I'd like to do is set my output level. So I'm going to just press the more key until I see output level. I'm going to raise that to -20. I want as much signal as possible without blowing away my receiver front end. Press enter. On the 8100, you can also press the spin knob as an enter key. Okay, the next thing we're going to do is I'm going to change the number of points. By default, I am scanning or sweeping across the entire span that's set here and stopping at 200 points to make measurements. I'm going to set that to an odd number, in this case 201. It'll become clear why I'm doing this. Okay. Now, I'm going to use markers to show where the high pass and low pass frequencies are. So I'm going to go to my marker mode here. I could set absolute, but in this case we're going to want to use delta markers because we are going to want to measure the difference between the the signal that is being notched out and the level that's being passed, or our insertion loss. So I'm going to select delta marker. You'll notice that what happens up here at the top is that it's going to give me a difference both in frequency and in levels between the two markers. Okay. I also prefer to use vertical bars, so marker type, vertical bar. You can immediately see why that's really handy. It makes it very obvious where my pass and reject are. Now they're not set at the correct frequencies yet, so let's go ahead and do that. I'm going to select marker 1. It's highlighted in red. You can see down here it has the frequency and the level. I'm going to set marker frequency. This will be my low pass frequency, 460. There we go. Now I'm going to select marker 2, set marker frequency to 465. All right. There we go. So we've got a pass or a low pass and a high pass frequency. Just so you know, right now I'm connected to the low pass side of the duplexer. Just so that's what you're seeing here. I'm passing the low and notching out the high. This duplexer has been previously tuned, and we'll play with it in a little bit. Okay, now let's go on to our next page. Okay, so there's a few things before we really dive into this that you need to know that will really help you get around and understand and better use your tracking generator. Some very important settings. First of all, as you can see here, my notch is off the bottom of the screen. Now this will all change when I normalize to calibrate my cable losses, but I want to show you that you can change the reference level. The reference level basically is what value is at the top up here. I can change it in single dB or in 10 dB increments. In this case, I'm simply going to change it back to 0. So that's a very important value. Typically, you're going to want to keep 0 as a reference level when you are normalized. Now, if you're not normalized, you may need to go lower. The next thing is vertical scale. And so on more 2 of 5, vertical scale, I'm currently looking at 10 dB per division. So if I want to be able to see the top and the bottom, I may want to go to a higher value. Now I can see both. If I'm down in the bottom of the notch and I want to get a clearer picture of what's going on, I can then decrease it, and then obviously I would have to change my reference level. We're going to start out at 10 dB per division. Finally, a really important setting that you need to be aware of is the resolution bandwidth, or RBW. This setting offers you wide, medium, and narrow. The main thing to keep in mind is your resolution bandwidth. The narrower it gets, the more precise your trace will be, especially when you're down in the bottom of the notch, but it will slow down the tracking generator. And so I usually recommend that while you're doing coarse tuning, let's say you're retuning from one frequency pair to another, and you're first of all just trying to get close, or coarse tuning, use the wide. As you start to narrow in, try to get a better tune, you can then go to medium or narrow. Another setting that can interact with this is the number of points. It defaults to 200. You can go up to 600 points. The more points there are, the better, clearer picture you'll have, but the slower it'll be. And obviously when you're doing fine tuning, you want it to be as responsive as possible. But please keep in mind, resolution bandwidth, if you're not getting a clear picture in the bottom of your notch, make sure your resolution bandwidth is as narrow as you can make it and still have it be responsive to your tweaking. Okay, now let's talk about calibrating it out, the system and cable losses, or otherwise known as normalizing. Okay, what you're seeing here right now is that our signal is fairly low, neg 20. We're injecting neg 20, but we haven't calibrated out the losses from the system. You can see the little jagged edges there. We haven't calibrated out the losses in my cable. Now I'm using fairly good cables, but still we need to calibrate out the losses. And the way we do this is we take the two cables that are going to the duplexer. I'm going to reach over here, disconnect them. In this case they're N-type connectors, and I'm going to take an N-type barrel, and I'm currently barreling the two cables together. All right, you're going to see the trace is going to be relatively flat, but you can see the little ripples, and you can see it's down at -20. So if you'll now go to more 5 of 5, you'll see the normalize function. Select it once, you can see that it's off. You can either use the arrow key as a spin knob. I just like to press it again and it will toggle to on. And I'm going to press enter. So what you'll see now is that we have a flat line at 0. So I am putting out -20 dBm, and I know that, and I've calibrated out the losses in the cable, so now I know exactly when I send a signal into the duplexer, I should be able to know exactly what that signal is, and anything that gets absorbed or reflected is going to show up. So let's hook it back up. Alright, so what you can see now is that my marker 1, which is my pass, and I'm on the low pass side, is showing that I am 0.5 dB down. This is my insertion loss. So as I said, I've already pre-tuned this duplexer, and you can see I've achieved a very low insertion loss. So when a signal comes through on the low pass side, it only loses 0.5 dB. And now let's look on our high side. This is my notch, and my notch is at 465, and you can see that it is, you know, negative 60, 70 down. Of course, resolution bandwidth right now is set to wide, so it's jumping around. So this is a good time to play with our resolution bandwidth. Let's go to medium, and you can immediately see that it's not jumping around as much. Let's go all the way to narrow, since I'm not actually going to adjust anything here. And you can see that I'm around -85 to -90, 95, depending. And of course you can see here that I'm off the bottom of the screen, so it's a good chance for us to use that vertical scale. 15 dB. Okay, now the important thing here is that I have this delta marker, and I can see that my two markers are 5 megahertz apart, which is great because that's the offset. But you can see here that it's subtracting this value from number 1 to number 2, and I'm getting about 90 dB of isolation. So when the transmitter is transmitting, my signal will be attenuated by -90 on the receive side. So I'm fairly well tuned. This particular duplexer is a 4-cavity pass reject, and I should be able to get a minimum of -70, but I was able to get to -90. Okay, you'll notice that the trace turned blue when I normalize. You'll also notice at the bottom of the screen it says trace normalized. Now the important thing, and I've noted that on the screen here, is that if you change the frequencies, it will automatically turn the normalization off, and you'll have to go through that normalization process again. As long as you don't change those frequencies, you're okay. And then in this case, I have everything set up, but if I were to go in and change the span, I would have to renormalize. Okay, that's normalization. Now let's talk a little bit about this duplexer. Like I said, it's a 4-cavity UHF pass reject duplexer. So there are 2 cavities on the high side, 2 cavities on the low side. I don't have access to the individual cavities. They're pre-wired together. So if you've got a duplexer where you can actually get to each cavity, it's always recommended to go tune each cavity first. It sure makes it a lot easier. It's not as confusing when you're looking through multiple cavities and they're all very close to each other. It takes a lot of tweaking, a lot of playing around to try to get them all perfectly lined up. Everybody has their own little method of doing that. In this case, I'm just going to have to live with it, and I've got 2 on the high side, 2 on the low side, my antenna connector in the middle. In this case, the cavities are tuned with push rods. These I find difficult to work with, but if you're gentle, make sure obviously that you loosen your nuts, and so that they'll freely move in and out. But again, if you bump them, you can detune it very quickly. Okay, so what is the procedure for aligning this duplexer? The first thing that you do is that you're going to set the pass frequency, and you do that by pushing or pulling on the rods. Again, you've got to make sure you loosen the nuts, and I'm on the low side. So here we go. How do we set this up? We've got the RF gen out port cabled directly into the antenna port on the duplexer, and I've got the low pass side into the antenna. That's already pre-selected, so I didn't have to set that. If you wanted to use different ports, you could. However, these are the best ports to use. You'll need to make sure you terminate your high side. So this is what I have right now, and you're seeing live the picture that I have. And this would be the point where I'm going to slightly detune this, if you'll bear with me. They're oh so finicky. All right, look at that. So I've moved one of my two filters, my cavities, and you can see there are two dips there. And the goal is I bring it back in. And again, you can see the response time is not all that great. So if I'm doing this, I'm typically going to be setting my resolution bandwidth, in this case probably to medium. It'll update a little bit faster. There we go. And again, as you get close, very small changes can make a huge difference. Now, if you're trying to get down there and really work the bottom of that notch, obviously you're probably going to want to zoom in or decrease your span. Just remember, when you do that, you will have to renormalize once you come out to your big picture again. But you can zoom in way down in on there and reduce your resolution bandwidth, and with the output level you can really get down to the bottom of the notch and get a clear picture. Okay, so that is on the low side. So now let's switch over to the high side. So if you'll give me just a second, I'm going to disconnect. I'm going to leave the RF gen out connected to the antenna port. I'm simply going to move my terminator onto the low pass side. And then we're going to move my high pass port into the antenna port on the service monitor. There we go. And you can see I've already pre-tuned this as well, but you get a good chance to check it. So what do we have here? On our high pass, you can see where we're passing, and we've got an insertion loss. Again, you'll notice I didn't change the frequencies, so I don't have to renormalize. It's still blue. 0.7 dB approximately of insertion loss. And down on the notch, I'm again down in the neg 80, neg 90, and you can see your isolation here is calculated by subtracting one from the other. So again, very well tuned. Now this is on the typically where you'd be adjusting the pass frequency using the plungers, the rods. Okay, so let's move on to the next thing. Now, how do you adjust the notch frequencies? That is done on this particular duplexer using very small screws. You'll need what's commonly referred to as a twiddle stick, which is basically a non-metallic screwdriver, so that doesn't affect the capacitance. What you're adjusting there is a small capacitor that's tuning the loop. Some duplexers do not have the ability to adjust this, so you're basically stuck with, by design, a certain offset, and you can shift when you shift the cavity, you are shifting both the pass and the reject, and by design it will have whatever offset in the case of a UHF 5 megahertz. So your duplexer may or may not have this, but if you do, you first do the plungers to do your pass, and then you come through and adjust your notches. Again, the way you hook this up is very similar. You go to the high pass, the low pass side. So again, I'm going to switch over. And again, we looked at this just a little ago. Putting my 50 ohm load on the high side. I'm connecting to my low side. And again, we're seeing that notch. And if I were to adjust the screws, you would see that move. On this particular duplexer, there are little covers, screw-on covers that I had to remove. So if you don't actually see the screw heads, You may have little screw covers that you need to get rid of there. Okay. In this case, it's already adjusted, so next you would do the high side. Again, I won't switch back over. We just looked at that. So now let's talk a little bit about return loss or measuring reflected power. So this is going to require a return loss bridge. You may or may not have one. If you want one, need one, we have a return loss bridge. You're seeing a picture there with the part number. This is something you can use for tuning antennas. It's also can be used with our distance default or cable fault locator. But in this case, if you have one, doesn't have to be ours, but just if you have a return loss bridge, you can use it to check the return loss. In order to get the optimal alignment, you need to balance your insertion loss and your return loss. Without a bridge, all you can do is see how much power is siphoned off by the RF filters when you're checking your insertion loss. You can't look at the power that's being reflected back to the instrument. Now, if you take a return loss bridge, what I'm going to do is I'm going to go ahead and set it up according to this picture. So what you'll notice is now that both of my cables from my instrument get disconnected from the duplexer. And now this has to be hooked up in the proper sequence. So the RF gen out port is generating a signal. It's hooked up to the source port because this coupler is a directional device. Then the reflected signal is going to be fed into the antenna port. Okay. All right. Now, again, I've got to calibrate out the losses in the cables, but now also the coupler. So let's go to Normalize. I'm going to turn that off. And you'll notice I'm down around below neg 30. I'm not connecting anything to the device under test port yet. So now I'm going to normalize. You can see now I've got a blue trace. It says normalized, and my line is at 0. Okay. Now I'm going to hook up the 50 ohm load to the antenna port on the duplexer, the common port. And let's connect the coupler onto the low side. Now, if you have one of these couplers, I would suggest using it in the first step to tune your pass. As you may have noticed when we're looking at the pass band, the pass is pretty broad. Now, you can change your vertical scale so that you can see what's happening as you adjust it. But once you see what it looks like here with the return loss bridge, you're going to just absolutely love this. So what I'm now measuring is the amount of power that's being reflected. So as my signal is being generated from my instrument, it is going to and past these two cavities. And the cavities are absorbing or passing the signal at the pass frequency, and at other frequencies they're not. They're reflecting it. And so you see that almost everywhere it's a flat top. It's reflecting, but at the frequency that it's tuned for, it is going to pass that signal right on through. Now, as you can see, that little notch there is not exactly centered, even though when we were looking at the other view we thought it was. So let's come back here. Whoops, sorry, I messed it up here. Very quickly going to reset my markers. Marker 1, apologize for that. Marker 1 is going to be at 460. I closed out the tracking generator by mistake. And there we go, we're good. Okay, so you can see that that is not exactly centered. What you're noticing here, oh, I'm going to change my vertical scale. Oh, and as you can see, it's no longer normalized since I exited the instrument. Alright, so let's disconnect it, renormalize it. Alright, disconnected, normalize off, normalize on. Reconnect it to the low port. Okay. There we go. Enter. Let's go back to more vertical scale. Let's accentuate that dip here. There we go. Oh, you see this a lot sharper than that pass band we were looking at. And this makes it very clear where we stand. So you can see I'm just being very gentle here, trying to slightly nudge. Notice how quickly that's dropping down once the two notches line up. Okay, let me change my vertical scale because I'm off the scale here. Okay, you can see I'm still not quite far enough. Give it a little nudge and you see how easy it is to go too far, and you see how big of a difference that makes. Now what you are seeing in terms of the level, I'm at -23, so I am, it's the dB of return loss. There we go, -37. Okay, so as you can see, this particular view makes it real easy to tune the pass and minimize the insertion loss. It's still not perfect, but I don't want to waste your time. Now you do the same thing over on the high side. Again, you just leave the termination on the middle port, switch it over. What I want to show you here is the end result. So once, and I realize it's kind of small, you may not be able to see that, but again, the delta is going to tell you your return loss. In this case, these values are in the -30 range. This is the formula. You don't have to figure it out or remember it. It's real easy to go online and find return loss to Visuar or SWR charts to convert it. And if you do the math or look it up on the chart, you'll see that below where we were, which is -33, we're looking at 1.05 to 1. So very well tuned. Anyways, that's the value of using the return loss bridge. And again, if you're interested in purchasing one, let us know. Okay, so further information is available if you want to contact one of us in the support team. There is a website with all our contact info. There are app notes and other documents in our document library. And again, my name is Chuck Cox. My email address, chuck.cox@freedomcte.com. And again, I want to thank you for joining me today. I hope this information was useful. If you're interested in other videos, freedomcte.com/videos. And I hope to see you again in another video. Goodbye.